In this lesson, we will be learning about naming more acids. Okay, first, from the previous lesson, you already learned how to name binary acids. For example, hydrochloric acid. Hydrochloric acid. Binary because it has two different types of elements. Ternary acids would have three different types of elements. They stem from your polyatomic ions that you memorized. For example, chlorate is ClO3 minus 1. Therefore, that's a 1. Therefore, you would need 1H, and this will become HClO3. To name this ternary acid, you would just add an ic in the end. This would be chloric acid. Okay, so the difference between binary and ternary, binary has the hydro in the front, and ternary doesn't. The way I remember it, binary has two items, a prefix and a suffix, while ternary does not have two items, just ic. Okay, so the ternary acid, sometimes they call it oxyacid or oxyacid. Why do you think it's called oxyacid? That's correct, because it has oxygen in it. So here in this lesson, we will be learning more different oxyacids. Okay, so we will be naming acids. Okay, to begin with that, we will first learn how to name some oxyanions. Okay, so oxyanions have oxygen in the substance, and they're anions because they are negative. An example of an oxyanion is chlorate. Chlorate is ClO3 minus. That's chlorate. Another example of an oxyanion is carbonate, which is CO3 minus 2. Another example is sulfate, which is SO4 minus 2. Okay, to turn the oxyanions into oxyacids, you would need to, I will show you how to do that later, okay? So here's an example. Chlorate is ClO3 minus. And to turn it into an acid, you add ic, and it becomes chloric acid, which is HClO3. Okay, but there are more oxyanions, so let us learn some more of that. So that's chlorate. There's also something called chlorite. Chlorite starts from chlorate, but it has only two oxygens, ClO2, and the charge is still -1. The charge does not change. Another oxyanion that stems from chlorate is chlorite or hypochlorite, which has ClO. Now it has one oxygen, still a -1 charge. So as you go down this list in the oxyanions, as you remove an oxygen, it becomes ite and hypochlorite, and the charge doesn't change. You can also add another oxygen, and the ending would be 8, but you add a per in front of it to differentiate from chlorate. So this perchlorate would be ClO. Can you guess what it would be? Yes, it would be 4 and then a -1. As you notice, you're starting from what you learned, you memorized as a polyatomic ion. The reason they call those the chlorates, the 8s, is because they're the most common. The other other oxyanions that stem from it are not as common. So the way you name it is you keep taking away oxygens as you go down, and you add an oxygen as you go up. As you go down, you ite. The way I remember it is you bite off an oxygen, and then you bite again. This helps. So the way I memorize it is you have a hippo, and a hippo or a hippopotamus has a big mouth, and they can bite two oxygens from the original. Okay, so let's try another one. Carbonate. Carbonate CO3 minus 2. You take away an oxygen, still the same charge. Take away another oxygen, still the same charge. You add an oxygen, still the same charge. The way you name it would be you bite, you hypo, bite another oxygen, and you ate, but you percarbonate would be that ion. Pause the video and fill out the rest of this table and this table, please. Okay, so Here you have sulfate, the one you memorized, SO3 minus 2, SO2 minus 2, and you can see the pattern, SO5 minus 2. This will be sulfate, sulfite, sulfite, persulfite, and that's not right. So this would be hyposulfite and 8-persulfate. Okay, going down here, you memorized nitrate, which is NO3 minus 1. Minus or minus 1 is the same thing, by the way. And then you'll have nitrite, hyponitrite, and nitrate. Pernitrate would be NO4 minus 1, NO2 minus 1, and NO minus 1. Okay. Chromate would be CrO4 minus 2. Phosphate would be PO4 minus 3. So chromite and chromite, hypochromite and perchromate, CrO5 minus 2, CrO3 minus 2, CrO2 minus 2. Phosphite, hypophosphite, phosphate, perphosphate, PO3 minus 3, PO2 minus 3, PO5 minus 3. The charge does not change. Okay, so those are all the oxyanions. Disclaimer, if they do exist, this is how they would be named. Some of these don't exist, though. I was just showing you the pattern. Okay, so now we can turn those oxyanions, these are all oxyanions because they're negative and they have oxygen in them, into oxyacids. Okay, so the way you do that is you just add an H in front of it. Here's an example. So this is chlorite, hypo, and 8-per. So it's ClO2 minus, ClO minus, ClO4 minus. Now, if you want to change all of these into acids, since they're all -1, each of them will need one hydrogen only. HClO2, HClO. Now, all of these are oxyacids because they have oxygen in them, and they have the H+, which makes them acidic. But to name them, to name the one that's most common is you just say ic. But if it is going down in oxygen, you now call it OS. This would be chlorous acid, and this would also be OS, but you put a hypo in the front. The prefix doesn't change. And if you go up, it's still ic, but it's now perchloric. As you notice, the prefix don't change. All the suffix becomes either ic or OS. The way I remember it is icky, acids are icky, and then you go up, the first two are the same, and then if you remove an oxygen, is you owe us money or you owe us oxygen, so you keep removing oxygen for the OS. Okay, pause the video and try these yourself. Okay, so sulfate is -2, SO3 -2, SO2 -2, SO5 -2. Okay, this would be sulfate, persulfate, ite, and this would be hypo. To change these into acids, it would be SO4 -2, so you'll need 2 H's, so it'll be H2SO4. This would then be H2SO3, H2SO2, H2SO5. This would be called sulfur. Sulfic sounds really weird, but they just go ahead and add the they go ahead and add the UR for all of them. Oh, shit. Sulfur, and then you add the ic. So this would be ic sulfuric, and then this would still be, and then the top would be ic per sulfuric, OS sulfurous, and hyposulfurous. Okay, so that's how you name oxyacids. Not to forget that this is how you're naming oxyacids, right? Don't forget to name the binary acids differently, okay? For example, HF, HCl, HBr. For those, these are not oxyacids. So do not name them like oxyacids. They're binary acids. The way you name binary acids is you add a hydro in the front and an ic in the back. Hydro, ic, hydro, ic. And then you add the stem. This is fluoric, hydrofluoric acid, hydrochloric acid, and hydrobromic acid. Just one word. Okay? Pause the video and try these yourself. Okay, so, forgot the negative one there. Okay, go ahead and pause the video. Okay, so this would be nitrate. If you add a H in the front of it, it becomes acid, and acids are icky, so it's nitric. Okay, so hyponitrite, it looks like the hypo bite 2 oxygens from the original. So the original's NO3 minus, take away 1 oxygen, take away another oxygen. So these are not it. I always start with the original, hyponitrite. That's just the ion. Now, if you want to change it into an acid, then you just take the hyponitrite. If it's hyponitrous, you always an oxygen, 2 of them. So it'll be into an acid, you add an H in the front. H, and the same thing as the top, HNO. Okay, let's try this one. The original is SO4 minus 2, which is sulfate. They added an extra oxygen, so this would be persulfate. To change that into an acid, because the H is in the front, now it is called persulfuric. You add an ic. Okay. Here again, phosphite. Phosphite stems from phosphate, which is what you memorized. Remove an oxygen, it's now PO4 minus, PO3 minus 3. Again, the charge does not change. So that's phosphite. Actually, this should be written phosphorus acid. So you owe us money. So it would be from the originals, phosphate. Phosphoric would be H3PO4. Phosphorus would be H3PO3, because you owe us an oxygen, you remove an oxygen. These are not them. Okay, and that's it.